So, if you've been working on rational expressions, you've probably seen that there's a few ways you can use the LCD. And I thought it would be fun, right? Fun, to compare the different ways to use the LCD. So, here are three different types of rational expression problems, and we're just going to now compare how we use the LCD in each situation. The first one is just your basic addition and subtraction of rational expressions. The next one is complex fractions, and the last one is a rational equation. Now, personally, I think it would actually be a very good challenge for you at this moment to pause the video and see if you know how to do each one of these and if you already know the different ways to use the LCD. I know a lot of times when you watch videos like this, you kind of want it like explained to you. But the thing about math, right, is that it's not a spectator sport. I know I say it all the time, but like this is exactly the type of place where you actually want to challenge yourself before you watch an explanation. So my 2 cents would just be that you try it yourself, because then if you don't get it, the explanation will mean more to you than if you just watch me do it perfectly. Because obviously I know how to do this, but if you're trying to learn to do this, then you've got to lean into it. Okay, so let's start with the first one. So the directions for this one are going to be to simplify. And the LCD for this is going to be x plus 5 and x plus 1. Okay, so there will be no solution because there's no equal sign. Okay, so that's the first thing, no solution. So the best we can do is combine these things. And because this is addition and subtraction, or this is a subtraction problem in this case, we can't cancel out the denominators. Everything just has to stay as is. So we want to rewrite this problem with the same LCD. So what do I need to multiply 9 over x plus 5 by to get to the LCD? I would need to multiply it by x plus 1. And what do I need to multiply the second fraction by to get to the LCD? In that case, I would need to multiply it by x plus 5. Okay, so here is the work now that I need to do. And I've talked about this in other videos where I talk about addition and subtraction. So the thing I want to highlight before I go any farther is that notice that I just rewrote the work that I need to do on top. I've just written it out over that common LCD, and now this kind of sets that game plan of what it is that I'm supposed to be doing. Because when I look at this, I go, okay, all I can do is combine, so I need an LCD. I've set up all the framework for that, and now the best I can do is just finish combining. So if I finish combining, this becomes 9x plus 9 minus 4x minus 20. This is x plus 5, x plus 1. So then I can collect my like terms. So I get 5x minus 11 over x plus 5, x plus 1. So that's all I can do for this one. And so it has to have a denominator because there's no way for me to cancel it out. So this is what it is. And so you kind of want to do like that sanity check when you're working on addition and subtraction problems to make sure that you had the LCD and that you didn't accidentally cancel it out. Okay, so now let's pivot to the next problem. So this is a complex fraction. Basically the same idea, right? Part of this problem I just reused. Now I have this other part of the bottom part of this fraction. So what's the LCD in this case? Maybe you want to pause and think about it for a second. But the LCD is going to be just x plus 5 and x plus 1. So I chose to use the same LCD over and over so we can compare it. Okay, so I'm actually going to erase this for a moment so that I can just remind myself, what do I actually do with this LCD? So with a complex fraction, so the idea here is that I'm actually multiplying the top and bottom by the LCD. And effectively what's happening is I am distributing this LCD to all the parts in the complex fraction. And so what effectively happens when we do that is we multiply the LCD by each part, which we talked about looks like this. So this is the work that we usually write down, right? And from here, then we can make a bunch of cancellations. So I can cancel out these x plus 5s. I can cancel out these x plus 1s. I can cancel the entirety of this out. And I can cancel out the x plus 1s. So what is this going to look like in the end after I've canceled everything? Here's what's left over in what I can multiply. Now, with complex fractions, you don't want to be cancellation happy with this. So we need to just go ahead and work everything out. So I distribute as shown, and then I just collect any like terms. So in the end, I'm going to have 5x minus 11 over negative 5 minus 3x. And so that's all that I can do with that one. I can't cancel any farther. These 5s here are not going to cancel out, right? We've talked a lot about cancellations. So for this one, I used the LCD to get rid of the denominators so that I could actually simplify all of this. And I'm still not solving for x, right? So now let's look at the last one. Here I have an equal sign, so I know that I need to be solving for x. And my LCD is still the same thing, this x plus 5, x plus 1. But now I'm utilizing the LCD. I'm multiplying every single part of the equation by that to get rid of the denominators. So if I multiply this first fraction by the LCD, I can see that I'm going to be left with 9 times x plus 1 because the x plus 5s will cancel out. For the second fraction, the x plus 1s will cancel out, so I'm going to be left with x plus 5. And then for this final part, so the whole denominator will cancel out, and I'm just left with 10. So now, when I go through and I do all my work, so let's see, I've got 5x minus 11 equals 10. And so I can go ahead, and I can add the 11 to both sides. So I have 5x equals 21, and so x will equal 21 over 5. And so now with rational expressions, so I use the LCD to get rid of the denominators, and I also have to double check that this will not cause a 0 in the denominator, which it will not, so we're all good to go. Okay, so you've really got to practice doing these 3 different techniques, and you really want to make sure that you feel comfortable identifying what type of problem it is, and then knowing what are you supposed to be doing with the LCD, because it's 3 really different things. This one, you can't get rid of the LCD. This one, you're using the LCD to get rid of denominators. And for this last one, you're ultimately going to get a solution, and you're also using the LCD to get rid of denominators. So practice this as much as you need, because I think it's not an obvious thing, and I think it's something that can kind of mess with your brain a little bit. Okay, so if you found this video helpful, consider hitting the like button or subscribing to the channel. I always super appreciate that. And I will talk to you guys in another video. Thanks for watching.